Good day, grade 12 learners. Welcome to today's mathematics lesson. My name is analytical. The lesson is brought to you by the Free State Department of Education in collaboration with Pagama Research and Development. Our topic for today is analytical geometry. I know we are busy preparing for the final exam, so I decided, because we'll not have a chance to cover this for our paper 2, hence I wanted us to do it earlier so that we are able to get better marks there, so that we continue to practice analytical geometry and statistics. Those are the topics we have done for paper 2, and I know we'll have ample time to practice paper 2, but let's continue to practice other topics as well. So our topic for today is analytical geometry, which has between 37 and 43 marks in our final paper. And the other topics that we have for paper 2, we have 4 topics. We have trigonometry, Euclidean geometry, we have done statistics. Today we are doing this one. So these two, we will do them a day before we write paper 2. So, but it doesn't stop us from practicing them, but there are things there that we'll talk about towards the exam, and we need them fresh before we write. Now, analytical geometry, as you are aware, has 37 to 43 marks. Our formula page, please always refer to the formula page so that we do not write wrong formulas and lose marks. And for our analytical geometry, you will find we mostly use the formula that we have here. That's the formula we have in our formula page. Now, we will also have this for our trigonometry, and sometimes you need to apply our trigonometry as we answer these questions, the area rule, as well the sine rule. If you are to find the length of a side, probably you might have to use this, but please let's always refer to our formula page. It's important. Now, the lesson's objectives for today, we have to revise analytical geometry learned from grade 10 and 11. We have to determine the equation of a circle with center at the origin and at any point labeled AB in the Cartesian plane. We also have to determine the equation of a circle with center AB and the equation not given in standard form, where we use the method of completing the square. We also have to determine the equation of a tangent to a circle and the length of a tangent to a circle. We might have to use theorem of Pythagoras there. Now, we also have to determine the relationship between circles, whether the circles intersect internally, externally, or do not intersect. We also have to analyze the relationship between the circle and the line, whether the line is a secant, meaning it intersects the circle at 2 points, or the line is a tangent, or the line does not intersect the circle. We have to look at that. We will refer to the CAPS document on page 47, as well as the examination guidelines for grade 12 for 2021 on page 8. Moving forward, our pre-knowledge. We know how to use the distance formula and how to perform calculations involving it, the midpoint of a line segment, the gradient of a line, the properties of parallel lines, perpendicular lines, and collinear points. We have to also know the angle of inclination, the equation of a straight line. We have to revise the properties of quadrilaterals, the basic ones, as well as the properties of triangles. Now, we'll quickly go over the theory, then we will answer questions after. We are given AB as a line segment joining the 2 points A and B. The following formula will apply. Now, for distance, we know that if we have A and B, it will be given as the x at b minus x at a squared plus our y at b minus y at a squared. Remember, it works either way, so we cannot always start with the coordinate at b. You can start with either. But now, let us be careful. In our formula page, you'll find it's x1, x2. So in other words, we have to use the coordinates of the point that we are given in the diagram that we'll be working on to avoid us making mistakes. So if it's PQ, it means it will be x at q minus x at p, or x at p minus x at q when we do the substitution. Let's use the coordinates of the points that we are given so that we do not make a mistake. We also have the midpoint, which is the half distance between the 2 points, and we use x1 plus x2 over 2. That's how it's given in our formula page. You do the same. Use the coordinates of the line segment that you are given. Now, we also have gradient, which is also known as inclination or slope. Now, the steeper the line, it means the gradient will have a bigger positive value, or sometimes it might have a negative value. So parallel lines, we know that parallel lines have equal gradients. So if AB is parallel to CD, then the gradient of AB is equal to the gradient of CD. It's an important property that we must always remember here. Especially when you are dealing with shapes, you'll be told ABCD is a rectangle, given that the equation of AB is that one, so you should be able to deduce the gradient of CD from the properties of that particular rectangle. Now, we also have perpendicular lines. For perpendicular lines, the product of the gradients will give us -1, and sometimes we have to prove that the angle is 90 degrees. We have to prove that when you multiply the gradients, we get -1. Then we can conclude that the two lines are perpendicular. Therefore, the angle between them will be 90 degrees. Now, we move on. The equation of a line. We have y minus y1 is equal to m into x minus x1. These are coordinates of a point that lie on that particular line, or we use y is equal to mx plus c. Now, we also have the angle of inclination, which is given by tan theta is equal to the gradient. So if our angle is acute, then we know that our gradient will be positive. If our angle of inclination is obtuse, then we know that the gradient is going to be negative, because tan is negative in the second quadrant. If we're to bring in trigonometry, that is why we will have our gradient as negative. Now, we should always remember that the angle of inclination is the angle a line forms with the positive x-axis. So we cannot have an angle of inclination which is negative or which is more than 180 degrees. Let us be careful when we do our calculations. Collinear points, these are points that lie on the same straight line. The gradient of AB must be equal to the gradient of BC, which also must be equal to the gradient of AC. So once you find the gradient of any of those 2 points being equal, it follows that the points are collinear, they lie on the same straight line. Then we look at the equation of a circle center at the origin. We will have our equation given as x squared plus y squared is equal to r squared. The center is at the origin. Our center is 0, 0. And then if we have our circle center at any point, you will find out that the equation of the circle becomes x minus a squared plus y minus b squared is equal to r squared. Sometimes we may be given the equation not in standard form. We may use the method of completing the square to write the equation in the standard circle equation form. Now, we also have the relationship between a circle and a line. If a line intersects the circle at 2 points, the line is going to be a secant. If a circle intersects the line at only 1 point, then we say the line is a tangent to the circle. There will be only 1 point of contact. And then if the line does not intersect a circle, then the line does not touch the circle. It's far away from the circle. Then we have circles that touch. Now, if the distance between the centers of the two circles is equal to the sum of the radius, then we say the circles touch externally, and we say the distance between the two centers is equal to the radius of circle 1 plus the radius of circle 2. I've used a capital letter and a small letter to show that the radii are not the same. So we will have the distance as equal to that. Then we have circles that touch internally. The circle is inside the other circle and they touch at only 1 point, and you are able to see that the distance is equal to the bigger radius minus the smaller radius of the other circle. We move on. Now we also have circles that intersect at 2 different points, and we are saying the distance is between the difference in the radii and the sum of the radii. If the distance between the two centers, remember we are having our center here, our center there, and we are saying this becomes the distance. But remember, this is our r from here to that point, and we have another r, the r to that point, small letter r. So this big R minus small letter r, that gives us the lower limit, and then if you add the smaller radius and the bigger radius, it gives us the upper limit. So when we calculate this distance here between the two centers, it's what we call a D. The distance must be between the difference and the sum of the radii. If it is between, then we know that the circles intersect at 2 different points. If the circles do not intersect, then the distance is bigger than the sum of the radii. There would be no intersection there, because that radii plus that radii, it's bigger than, the distance is bigger than the sum of the 2 radii. And then we have the last condition where we are saying the circles, one circle can be inscribed inside the other circle. When they share a center, we say they are concentric circles, but if they don't, then we know that the distance is less than the bigger radius minus the smaller radius of the smaller circle. Now we have that as the distance. With that being said, I would want us to practice answering questions for analytical geometry. I'll ask you to answer 3.1 up to 3.5, and I'm going to give you 12 minutes. Now, I hope you managed to try and work out some of these questions. What I'll encourage you to do, always check if all the information is there in the diagram. It always helps if you add information to the diagram because it makes your life easier. And as you get these answers, please add them to the diagram. You will find they will make life a bit easier. Let's look at our question. We are given the diagram and we are told P, Q, and R are the vertices of triangle PQR. M is the midpoint of QR. N with coordinates A and B is a point on PM in the second quadrant. The equation of QR is given by y is equal to negative 3x plus 9 is equal to 0. The angle of inclination of QR is given by theta. We have to calculate the coordinates of M, the x-intercept of the line PM. Now, we have to find the coordinates of M here. How do we find the coordinates of M? If you check, QR is a line and you are told that the equation of this line is given by, that's my r, y is 2y minus 3x plus 9 is equal to 0. Remember, we should be able to write this in standard form, y is equal to mx plus c as well. We calculate the coordinates of M. So what is going to help us find the coordinates of M? If we check, M here becomes the x-intercept of the line. So if M is the x-intercept of the line, how do we find the x-intercept? We let our y to be equal to 0 because already we know that the y-coordinate here should be 0 because M is the x-intercept. Then this is what we did. We will substitute our y as 0 and we should get our x as 3. Therefore, the coordinates will be 3 and 0 there. You get 2 marks there. We have to determine the equation of PM in the form y is equal to mx plus c. Now, remember, write these coordinates in the diagram. There is our line PM there. It's a straight line. Now, I'm able to see that you have coordinates at P and we have coordinates at M. So we need to first of all get the gradient of PM before we are able to get the equation of a line. How would we get the gradient of PM? We use the coordinates of M and the coordinates of P. So to find gradient, we use the gradient formula. It will be 12 minus 0 over negative 9 minus 3, and that should give us our gradient as negative 1. You are able to see there the angle of inclination of the line PM. It's going to be obtuse, hence we will get our gradient as negative 1. So we'll get a mark for getting the gradient. And then we have to find the value of C. And for us to get the value of C, we will use y is equal to negative x plus c. I've highlighted the coordinates of P there as negative 9 and 12. So we substitute them. Where there is x, we'll put negative 9, and where there is y, we will put 12, and we get the value of C as 3. And the equation of the line will be given by that. So you'll get a mark for substituting gradient and the coordinates of a point. Remember, you can also use the coordinates of M, which are 3 and 0. It should give you the same equation. We get the equation, and that gives us the 4th mark there. We move on. 3.3. We have to calculate the size of theta. If you check, theta is the angle of inclination of our QR. But remember, we are given the equation of QR as that one. So I will encourage you to write down this equation of a line as we are having 2y is equal to 3x minus 9. Divide by 2. This will give us y is equal to 3 over 2x minus 9 over 2. So from there, because it's now in the form y is equal to, it means the gradient of QR, we can deduce it as 3 over 2 there. Here we say it is 3 and 0, and we are able to deduce the gradient of QR using the equation 2y minus 3x plus 9 is equal to 0 there. So we use the angle of inclination is given by that. So for knowing the concept that tan theta is equal to the gradient and getting our theta as 56.31 degrees. Remember, unless stated otherwise, we round off our answers to 2 decimal places. We have to show that B is equal to 3 minus A. Now, in 3.2, we calculated the equation of the line PM, and if you check, P, N, and M are collinear points. They lie on the same straight line. So it means if we substitute the coordinates of point N, we should be able to get something. So we are using y is equal, the equation we got in 3.2. We substitute A and B, and that will give us negative A plus 3, which is the same as 3 minus A. We get our 1 mark there. We move on to 3.5. Now, we have to determine the value of A and B if NQ is equal to 5 root 5 units. Now, NQ is a distance between 2 points, so we are going to be using the distance formula. So, how do we use the distance formula for the length of NQ? We are going to substitute our coordinates of Q and the coordinates of N. We form equations. So we'll have A minus 9 squared plus B minus 9. So we have used the coordinates of N and the coordinates of Q. But we know that B is equal to 3 minus A. So where there is B, we'll substitute with 3 minus A. Distance formula. We substitute for B, and then we will square both sides, expand, and write our equation in standard form. Then we will have our both values of A. Our A will be equal to 4, or our A will be negative 1. But remember, if you check our point N, it's in the second quadrant. And in the second quadrant, the value of X there should be negative. So A equals to 4 in this case is not applicable because the point N is in the second quadrant and our X value there is going to be negative. Hence we choose that one, our A as negative 1, and then we substitute and get our B as that. So you will get a mark for the value of B as well as for the value of A as negative 1. Then we get our 5 marks. We move on now. I will also give you 8 minutes to answer question 3.6 and 3.7. Welcome back. Now, I hope you managed to answer 3.6. Now, for our 3.6, remember, we are told that M is the midpoint, which means the distance from here to there is that. And remember what I said, if you add information to a diagram, it will make your life easy. So if it passes through its center is the origin, we know that this is 0, 0. And it passes through point R, but we do not have the coordinates of point R. So what do we need to do? We must get the coordinates of point R using our midpoint. And remember, for us to get the coordinates of the midpoint, we are using our equation for the midpoint, our x at R plus our x at Q is 9 over 2, like that. Our y at R plus our 9 over 2. This will be equal to the coordinates of the midpoint, which are 3 and 0. So from there, that is where these equations are coming in. You take the x at R plus 9 over 2, it is equal to the x coordinate. Hence, we will have that one there, and we'll get our coordinates of R as negative 3 and negative 9. From there on, we are using the equation of a circle, x squared plus y squared is equal to r squared, because our center is at the origin. We then substitute the coordinates of r into the equation and we get our r squared as 90, and our equation becomes x squared plus y squared is equal to 90. 3.7. We are told that the acute angle between the lines QR and the equation y is equal to mx plus 4 is 45 degrees. We have to determine the possible values of m. Now, for us to answer that question, remember, we let the angle of inclination of the line y is equal to mx plus 4 be that. And you will realize this is how this would look like, because the angle of inclination between QR and another line is 45 degrees. There we have our 45 degrees. And in the process, you are forming a triangle. And if you look at that triangle, the angle of inclination of our line y is equal to mx plus 4 is beta, we are able to use beta plus 45 degrees must give us the exterior angle, which is 56,31. Hence, from there on, we are able to determine the size of angle beta, which becomes, our beta becomes 56,31 minus 45 degrees, and we get beta as 11,31 degrees. But remember, for us to get our m, we use tan beta is equal to the gradient. So where there is beta, we'll substitute 11,31. Hence, we'll get our gradient as 0,20 there. Or alternatively, we can say the acute angle between QR and the line, still it's 45 degrees. But we calculated our angle of inclination for the line QR, which means if you check, you are having that small triangle there. And you are able to see that this angle here will also be 56,31 degrees. These are vertically opposite angles. From there on, you have this angle. The sum of these two interior angles is equal to our exterior angle, in which case that becomes our beta there. So we are going to use that, and we will have our beta as 101,31 degrees, and then we want tan of 101 degrees, 31, and then this will give our gradient as negative 5. Interesting question, and we must be able to get this. So our M can be that, our beta is that, then we use our angle of inclination. So it's important to draw a diagram, we visualize what's happening so that we are able to get the marks that we need. We move on now to activity 2. So for our activity 2, I am going to give you another 12 minutes so that you answer question 4.1 up to 4.3. Welcome back. I hope you were able to answer this question. Now, it is important that we read the information before we answer the questions again. So we are told that we have a circle, center M, the bigger circle, and we know that it touches the x-axis at point C and the y-axis at point B. A second circle with equation x squared plus y squared plus x minus 3y plus 2 equals to 0 passes through point A and M and intersects circle M. Remember, circle M, it means circle center M at A and B. Now, the equation of the common code AB is given by y is equal to negative x plus 1. That's a common code that intersects both circles. Now, we have to determine the coordinates of the center and the radius of circle which passes through B, M, and A. So we want the center of the equation of the circle. Let me name it N. So if this N is the center of the circle that passes through point A, M, and B, these are points on the circumference. So we have to find the coordinates of N. How do we find the coordinates of N? We are given the equation. We use the method of completing the square, and we'll have our left-hand side will get a mark, and the right-hand side, remember, whatever we have here, it's half the coefficient of x, which is half, and half the coefficient of y, which is negative 3 over 2. You square it, you also add it on the right-hand side. So from there on, we'll get our equation as x plus half squared plus y minus 3 over 2 squared is equal to, when you add these, they will give you half, which means the coordinates of the center, we know that the coordinates of the center, our equation of the circle is x minus a squared plus y minus b squared is equal to r squared. So we have written it in that form here. That's our standard form. So we'll take the x value at the center then becomes negative half, and the y value at the center becomes 3 over 2, and our radius becomes the square root of what we have on the right hand side. This is our r squared in this case, which is that. So we'll get a mark for this and a mark for the coordinates of the center. So you get a mark for the right hand side and a mark for the left hand side there, giving us the 4 marks. We move on to 4.2. We want to calculate the coordinates of point A. Remember, point A is a common code. How do we get the coordinates? Remember, this is a point of intersection between the two circles. So we have the equation of the smaller circle and we have the equation of a line. We are going to use those to help us find. So our equation 1, it's y is equal to negative x plus 1. This is the equation of the chord AB. That's chord AB. And then we have the equation of the circle. We substitute, and where there's y, we will put negative x plus 1. We square that. There's a lot of algebra involved. We need to practice. Then we get 2x squared plus 2x is equal to 0. Highest common factor there, it's 2x, which means our x will be 0 and negative 1. But remember, we want the coordinates of point A, so which means here at point B the coordinates are 0 and 1. So we want the coordinates of point A. So our x is negative 1 and we substitute and we'll get our A as having coordinates negative 1 and 2. This was 5 marks. We substituted, we simplified and we got our equation in standard form. We got both values of x, and then we rejected the 0 and chose the -1 and the 2 there as the coordinates of point A. Interesting question. 4.3, we have to show that the equation of the circle centered at M is x squared plus y squared plus 2x minus 2y plus 1. Remember now, we can't use this equation to show that the center will be that. So this equation must come at the end. How do we do it? We have our y is equal to -x plus 1, which means the y-intercept at point B here is going to be 0 and 1. So if it's 0 and 1, it means the y value at point M is going to be 1, because this is the equation of MB becomes y is equal to 1. We have to find the x value at point M. Remember, this is a point on the circumference of the smaller circle. So you will find out that when you substitute into that circle equation, it will give you the center, the coordinates of M as -1 and 1. And when we substitute the coordinates of point B there, it will become 0 plus 1 squared plus 1 minus 1 squared is equal to r squared, and we'll get our r squared as 1. We expand. This is the standard circle equation. If we expand it, we'll get x squared plus 2x plus 1 plus y squared minus 2y plus 1. We transpose the 1 and we get -1, and that will give us the equation as x squared plus 2x plus y squared minus 2y plus 1 is equal to 0. Hope you are able to see that part, because we have 1 plus 1 minus 1, we'll get a plus 1 there. So this is how we'll get the equation. So we must be able to practice with both forms of the equation of a circle. We move on now to question 4.4. We have 4.4, 1 and 4.42. I will also give you 8 minutes to answer those 2-part questions. Please read the information first, and it starts now. Welcome back. Apologies, 4.41 there. There is the coefficient of x there, it's 4 minus 2k, and then the equation becomes 2x squared plus 4 minus 2k x plus k squared plus 2k plus 1. And that question is 3 marks. We have to calculate the numerical values or value of k, and that question is 5 marks. Let us look at this question. Now, you will realize that we want to show that the equation, it's the x is missing there, it's given by that. So how will we do it? Our y is given by negative x plus k. Our equation is given by x squared plus y squared plus 2x minus 2y plus 1. So where there is y, we will substitute with the equation of a tangent. Remember, a tangent only touches the circle at one point, and this will give us our equation as such. Now, we will then have to expand, and we get our answer as that, and then we will take out our common factor, and it will lead the equation to that. Substitute, expansion, simplifying, and then we will get our equation as that. So taking out a common factor, coefficient x, we have got a variable x, this is now a constant, hence we'll take that one out, and x squared plus our x squared will give us the 2x squared there. We move on now to the next part. Let's check. Now we will have, we are supposed to calculate, I think I jumped one slide here, let me quickly go back. Right. Let me quickly go back. Right. Right. So for 4.4.2, remember we are supposed to find the numerical value or the numerical values of k. If you check our equation, we got it as that. Now, for us to find the numerical value of k, we are going to use our discriminant. Now, if you check, this is in the form ax squared plus bx plus c equal to 0. So, for us to find the numerical value of k, remember our solution there is going to be real. So, we are going to now have to find, so we have one real solution, which is a repeated root because it's a tangent, it touches at only one point. Our a is equal to 2, our b is 4 minus 2k, and our c is going to be k squared plus minus 2k plus 1 there. So we have to find our delta, and we equate it to 0, b squared minus 4ac. So our delta becomes 4 minus 2k, we square that, minus 4, our a is going to be 2, our c is going to be k squared minus 2k plus 1. Now, when we simplify this, this will give us 16 minus 16k, and then plus 4k squared minus, that will give us 8k squared, and then this will give us negative 8 times negative 2, we'll have plus 16k, and then negative 8 times positive 1, this will give us negative 8. When we simplify this one, we will get 6. Let's have 4k squared minus 8k squared, we'll get negative 4k squared, and then we'll have negative 16k plus 16k, it will give us 0. Then we'll have 16 minus 8, this will give us plus 8. So from there on, we know that our delta is equal to 0. Therefore, we will get negative 4k squared plus 8 is equal to 0, which will give us our negative 4k squared is equal to negative 8, and then we'll get our k squared is equal to, is equal to 2, because we'll divide both sides by negative 2. So our k becomes plus or minus the square root of 2. So those are the numerical values of k, plus minus the square root of 2. Interesting question. As you are aware, you are able to see that we integrate topics here. So you can't say because it's paper 2, there's no algebra. There's a lot of application of algebra here. Hence, we need to practice our nature of roots as well as we are answering these questions. Now, our next activity, you are going to do this one at home. It's the June 2023 paper 2 question number 4. You will do it later on when you get home, because time is not on our side. But there is another aspect that I need us to look at. You will be able to see it when you're answering those questions. Equation of a tangent, how do you get it, and so on. These are the things that we must do. Remember, try to practice. If you give yourself a target, today you are doing analytical geometry, do both question 3 and 4 from different years, so that you are able to mark and see how much you are getting. There are a lot of questions from the exam bank. Please, let's practice. Try to do as well. Paper 1, you balance up the questions. Do not concentrate on only one paper. Let's balance up the papers. If today you do analytical geometry, that's paper 2. Tomorrow, so that you do not forget, you do one question on functions and you alternate, something like that, so that we are able to get good marks at the end of the year. So you are going to practice using this question later on, and you should be able to get these answers as you are practicing. Now, that is the second part as well. You will do it at home, and let's keep on practicing. Now, in summary, it is important that for analytical geometry, we analyze the diagram and the given information to identify what can be used. Sometimes the information is in the statement. Make sure that you add the information to the diagram. Draw additional lines. If it says parallel lines, indicate on the diagram. It will make you visualize what is happening. Remember, diagrams are not drawn to scale, so we can't measure anything on a diagram. We must use the diagram effectively. As I have indicated, add information to the diagram. It will simplify things. Label correctly. Use the correct notation for angles, sides, and so on. And always add the answers that you are getting to your diagram. It will be helpful to get marks there. I've mentioned this one. We add information to the diagram. We draw additional lines so that it's clear what we are answering. Remember the angle between QR and a line. You must be able to draw a line so that you're able to visualize and see. Paper 2 is easier than paper 1 because there are diagrams, and diagrams make it easy for us to visualize, but the challenge, we do not add information to the diagrams. The properties of our triangles and quadrilaterals must be revised thoroughly. We should also look at how do we calculate area and perimeter, because sometimes those questions are asked to find the area of a shape. We use the properties of those shapes, so we must know the formulas for finding area and perimeter of our shapes. We did that in grade 11. Let's use color to help us visualize better, and we refrain from making assumptions. If it's not stated that it's a diameter, we can't assume. We can't assume it's a right angle. It has to be proven, or we have to see it or work it out to show that it's a right angle. With that being said, I thank you. Let's continue to practice mathematics, and the end is near, but let's keep on keeping on. We practice every day. I wish you all the best. As you start your exams next week, let's continue to pass well.